Hello again, Math Minions. Here we are. We are on page 102. We've looked at polygons. Now we're going to look specifically at triangles and their angles. All right? Now, when we're deciding what kind of triangle is it, there's two different things we look at. We look at the sides and we look at the angles. So let's look at what we've got when we're looking at sides. And at this point, we're going to want to use something called a ruler. I know. So first up, I have pictured here an equilateral triangle. You can probably guess that an equilateral triangle has all sides. All three sides are of equal length. Right? Equal length. So that means going from A to C is the same distance as C to B, and it's the same distance as B to A. Now, also notice that there's these lines like we did in the last one. There's one line here, one line here, one line here. Because they all have one line, it says, hey, these are equal. And this, and this means all three angles are equal. Really, that's why it's an equilateral triangle. So because we're looking here at length, or the sides, we would take a ruler to determine, line that up there and go, and it's like, look at that, we've got, what is that? If those are 16ths, so that's 15, 14 16ths, which is 7/8. So this is 7/8 of an inch, and then I would check, and sure enough, 7/8 of an inch. And then the other one would be 7/8 of an inch. So each side is 7/8 of an inch. Normally, I like using metric because it's just plain easier. Watch this. Start at 0 and we go, oh look, there's 20 because there's 10, 20 millimeters. 2 centimeters is 20 millimeters plus one more, so 21 millimeters. Okay, so you can also say it's 21 millimeters. So you don't have to try to mess with fractions, and that's okay. So either way, by the way, this is called a protractor, and this is what we'll use to look at the angles. So the next one on this sheet says isosceles triangle. Try saying that, isosceles. No, seriously, say it. Isosceles. Yeah, isosceles triangle. That means that two of the sides are of equal length. Right? And you can tell in this picture, it's like, look, 1, 2, there's no line here. I could go boop, boop, and show that this is one the same and this is different. 1, 2 angles are the same. So I could do that and say that's different, right? That's how we note on a picture without having to write everything down. That's how math people shorthand it, all right? So this is isosceles. So if I measured, these two would be the same length, and this one is a different length. Okay? The third kind, when we're looking at sides, is called a scalene triangle. Now this one, look at the picture. Do you notice? 1 line, 2 lines, 3 lines. That means that none of the sides are of equal length. Okay? All 3 sides of the triangle are different lengths. That makes it a scalene triangle. All right. Now I want to show you something before I move over to angles. Down here at the bottom, you see where it says note, straight angle equals 180 degrees. I want you to also note the sum of all angles in a triangle equals 180 degrees every single time. Oops, slide that up there. The sum of all angles in a triangle equals 180 degrees every single time. Okay, so this up here, the equilateral, they're all 60 degrees. 60, 60, 60 is 180. Okay, this is a smaller one, so these two will be a little bit bigger. And then this one, this is a big giant number, and this is going to be less than and less than. Okay, and here's what I mean by greater than and less than and all that. All right, let's switch over to the triangles based on angles. Okay, we've got this first one is a right triangle. Now, it's called a right triangle because one angle is equal to 90 degrees. And that would be this one. You always see this little box here. When they put that box there, it tells you this is 90 degrees. Okay? It is a right triangle. Okay? So that means these two here are going to be less than 90 degrees. Because together they have to equal 90 degrees, right? Because if all three of them total up, you add it and you get 180. Well, we've already used 90 here. So these two have to be less than 90. The next one is called an acute triangle, okay? And I always think of it as this. It's acute because it has acute angles. They're all acute. They're so acute. Yeah, cute. All right, you don't get my humor. So, an acute triangle has all three angles are less than 90 degrees each. Okay, less than 90, less than 90, less than 90. Remember up the equilateral, I said it was 60, 60, 60. This is not necessarily an equilateral acute triangle, and you can have things be in both, okay? But it's less than 90, less than 90, less than 90. So let's just check this out here. We've got this goes at the vertex. And now you would normally draw a line, and it looks like it's somewhere between 60 and 65. I could use my little ruler here and go along the line. And oh no, it's looks like it is 60. So the picture didn't look like they were all equal, but they are apparently all 60 degrees. So this would be an equilateral acute triangle. All right. So this is not 60, 60, 60, which is really less than 90, less than 90, less than 90. All right. Now, this one is called an obtuse triangle. All right. It's obtuse, and here's why. You've got two angles that are less than 90 degrees. Okay, up here in the acute we had all three. Down here we've got two less than 90 degrees each, and that leaves one is greater than. That's right, greater than 90 degrees. So if you look here, this one right here is 120 degrees. It's greater than 90 degrees. Okay, greater than 90 degrees. That means this one is less than 90 degrees. And this one is also, whoops, I did greater than, less than. And this one is also less than 90 degrees. Okay? Because remember, they all three have to equal 180. Well, if that's 120 already, we only have 60 more. So it's probably 30, 30, and 120. Okay? So what you're going to be doing in your math practice is identifying which kind of triangle you have, but you'll also be needing a ruler and a protractor because you're going to look at checking what is the angle, how many degrees is the angle, and you're also going to be measuring the length of the various sides to prove that it is the kind of triangle that you say it is. Okay? So, have fun, and I'll see you when I see ya. Bye!